Hello and welcome back. In this lesson, we're going to explore another one of AWS's application services, and that is AWS API Gateway. So over here in the Orion papers, let's click on API Gateway. And then also over here in the AWS console, you can find API Gateway under Application Services right here as API Gateway. So in a few minutes, we'll make sense of this entire diagram here, but first I want to dive into API Gateway Essentials so we can get first a fundamental understanding of what API Gateway is. So let's start off by talking about exactly what API Gateway is. An API Gateway is a fully managed service that allows you to create and manage your own APIs for your application. API Gateway acts as a front door for your application, allowing access to data, logic, and functionality from your back-end services. So again, with that in mind, now let's jump back out and take a look at our diagram. So let's say that we have an application running on a combination of AWS services. So that can be EC2, whether it's through your own EC2 instances that you provision or through, say, Elastic Beanstalk, or also Lambda functions. So this is your application backend. You also have a front end to your application. So that could be a mobile app, websites, services, but you have users that are going to be using your application, and you need to be able to communicate between the front end and the back end. Well, that's where API Gateway comes into play. So you can create your own API so that your front end can communicate with your back end, and you can control all aspects of that particular API. So jumping back into the essentials here, what are some of the main features of API Gateway? Well, first, you can use it to build RESTful APIs, right? With all the components of a RESTful API being resources, methods, and settings. You can deploy APIs to a stage, meaning that you can have different environments, so a dev environment, a beta environment, a production environment, and you can have APIs specific to those environments, and that is done through creating stages in API Gateway. Now, you can also, within each stage, then have its own throttling, caching, metering, and logging, which we will talk about over the next few minutes. We can also do version controlling, so we can create a new API version by cloning an existing one. So you can create and work with multiple versions of an API, and again, that is version controlling your API. So you can have version 1 of your API, you can then deploy out version 2, version 3, and then you can also roll back to previous API deployments. So let's say that on your beta stage, you have version 1 of your API, you can then update that to version 2 of your API. You can test that out, and then you can deploy that out to your production environment for your APIs. And if at any time any of those don't work the way that you want them to, you can always just roll back to version 3, 2, or 1, depending on which version you want to roll back to. So you can version control all of your APIs using API Gateway. You can also deploy out and roll back any of those versions that you use. You can also use custom domain names. So custom domain names can point to an API or to a particular stage. You can also create and manage API keys for access and meter usage of the API keys through Amazon CloudWatch logs. So again, you can just create as many API keys that you like to give access to your API with the ability to monitor various metrics through CloudWatch. And since we can monitor our API usage through CloudWatch, we can then set throttling rules based on the number of requests per second, meaning for each HTTP method that gets called. Now, requests that go over the throttle limit they've put in place will return a 429 response, and that's important to remember. Now, in terms of security, security is set up using Signature version 4 to sign and authorize API calls. So temporary credentials are generated through Amazon Cognito for mobile and security token service. Now, what are some of the other benefits of API Gateway that you should be aware of? Well, we have the ability to cache API responses, and I'll talk a little bit more about that in a minute. We also have the ability to have DDoS protection through CloudFront. There is also SDK generation for iOS, Android, and JavaScript. API Gateway also supports Swagger, which for those who don't know is a very popular framework of API dev tools. And there's also the ability for request response data transformation. So we can put JSON in and say get XML out. So it does allow for data transformation, which can be very useful. So let's back out here and take a look again at our diagram. And let's talk about the workflow of API Gateway. So what happens here is that if we have a user, so whether it's somebody using a mobile app, a website, one of our services, the request is going to come in over the open internet through HTTPS. And actually, the first thing that's going to happen is it's going to hit CloudFront. So API Gateway uses CloudFront's global distribution network as the entry points for everything coming into API Gateway. Now, this does several things. So let's take a look specifically at CloudFront and how it's used with API Gateway. So API Gateway benefits from using CloudFront infrastructure. So as we know, CloudFront has built-in distributed denial of service or DDoS attack protection and mitigation, right? So if there is some nefarious user out there and they decide to attack your particular application, none of the requests are ever going to hit your back end. CloudFront is always going to protect your backend by taking all of the requests. So again, CloudFront just provides built-in DDoS protection for your application simply by just utilizing API Gateway. Also, all CloudFront edge locations become entry points for your API into your backend. So what does that mean? It just means basically that the benefits are reduced latency through the use of CloudFront edge locations, since those are located all around the world, and then also improve protection from DDoS attacks. So once the request comes in through CloudFront, it does come into API Gateway, and API Gateway also has the ability to cache API responses so that if there is a duplicate request, it doesn't have to again hit your back end. So let's click on the API Gateway cache here and just understand a little bit more about this. So API Gateway will cache API responses so that duplicate API requests do not have to hit your back end. So this is a couple of things. One, it reduces the load on your back end and also speeds up calls to your back end. So that's a very good benefit of having caching via API Gateway. You can also configure a cache key and time to live of the API responses. So you can set cache responses to automatically expire after a certain amount of time, in which case then any duplicate responses would then have to go to the back end and get the new or updated response. And also, caching can be set up on a per API or per stage basis. So again, when a request comes in over the open internet through HTTPS, will come in through an edge location, which provides you with lower latency to the user as well as DDoS protection, but then it's also going to check to see if a response for the request has already been cached. And if it has, it will just return that response. And if not, it will then go to the back end, pull the proper information, and then send it back out to the user. Now also, CloudWatch is used for monitoring. And as I mentioned before, it's mainly used to monitor the metrics, but then also to control throttling. So if there's a lot of requests coming in, it may hit a throttling limit, in which case it is going to prevent any further requests from hitting your back end to make sure that we don't have any server issues from having too many requests. So in terms of monitoring though, what can you do? Well, CloudWatch can be used to monitor API Gateway activity and usage. So monitoring can be done on the API or the stage level. Throttling rules are monitored by CloudWatch. Monitoring metrics include such metrics as caching metrics, latency metrics, and detection error metrics. Also, method level metrics can be monitored, and you can also create CloudWatch alarms based on these metrics. So you can create your own custom alarms based on any of the metrics that API Gateway provides to CloudWatch. And then you can set up triggers for something like SNS or Lambda functions based on what may occur in terms of metric thresholds in the APIs that you have created. Also, you may notice that I have another section up here called Other Public API Endpoints. Well, one of the great things about API Gateway is that it can also send out requests or incorporate other public API endpoints. So anything else that's on the internet that's an open API can be communicated to through API Gateway. So you could actually have an older or on-premise or legacy application that has its own APIs, and you can set it up so that requests that come into API Gateway can also reach out and request information from other APIs as well. So you can have your application backend based on Lambda functions and EC2 endpoints, but you can also have a backend by connecting to and sending requests to other established public API endpoints. So you can also use this as a slow migration. If you have an older legacy application that has public APIs, you can slowly move over that application into AWS and slowly migrate over the API usage as well. So, in summary, what's important to remember is that API Gateway allows you to build and control your own APIs for your own application. And it has some built in features by connecting to other AWS services such as CloudFront for reduced latency and DDoS protection, the ability to cache so that you don't have to constantly be hitting your back end services for responses, and also the ability to monitor using CloudWatch for monitoring, and the ability to access other public API endpoints via AWS API Gateway. So with that, we will conclude this lesson. Thank you for watching. You may now move on.